Welcome. This is Vision Mathematics. My name is Thomas Vanda, and I'm going to take you through the lesson on this video. Lesson number 6. In this lesson, we will be consolidating the use of double angle formula by means of further examples. Example number 1. Prove that cos 3a equal to 4 cos cubed a minus 3 cos a. Now we do not have formula for triple angles, so we rewrite 3a as 2a plus a and expand that using compound angle formula and then observe what happens. Thus, by rewriting 3a as 2a plus a, we have cos 3a equal to cos 2a plus a. Then we expand this using compound angle formula. This gives us cos 2a cos a minus sin 2a sin a. Now we must get rid of the double angles because the result that we want here does not have double angles. We use double angle formula to achieve that. Now the double angle formula for cos 2a has 3 options. We have to choose carefully. We are guided by the result we want to produce here. It has cosine only, so we choose the one which has cosine only, and that is 2 cos squared a minus 1 multiplied by cos a minus the double angle formula for sin 2a is only 1, so we have to make do with that one. So that's minus 2 sin a cos a multiplied by sin a, then multiplying cos a into the bracket, we have cos a multiplied by 2 cos squared a giving us 2 cos cubed a. Cos a multiplied by minus 1 gives us minus cos a. And here we have sin a multiplied by sin a giving us sin squared a. So the result here is minus 2 cos a sin squared a. Now we only have sin squared a to deal with, and we use the trig identity which says sin squared a equal to 1 minus cos squared a. So we have 2 cos cubed a minus cos a minus 2 cos a, and substituting for sin squared a we have 1 minus cos squared a. Then multiplying minus 2 cos a into the bracket, we obtain 2 cos cubed a minus cos a, then minus 2 cos a times 1 gives us minus 2 cos a. Minus 2 cos a times minus cos squared a gives us plus 2 cos cubed a. Then observing that 2 cos cubed a and plus 2 cos cubed a are like terms, we add those to obtain 4 cos cubed a. Then minus cos a minus 2 cos a are also like terms. Adding those we get minus 3 cos a, and this is the required result. Here's our next example. Evaluate without the use of a calculator. Sin 35 degrees cos 35 degrees all over tan 225 degrees cos 200 degrees. Now from our grade 11 work, we remember the technique: reduce all angles to acute angles. So we have angles here which are not acute angles. Is 225 and 200. We must first of all reduce this to acute angles. So that's sin 35 degrees cos 35 degrees over tan 225 cos 200. This is equal to, these ones are already acute angles, leave them like that for the time being.
Now 225 is in the third quadrant, and it is 180 plus 45. And in the third quadrant, the tangent function is positive, so this reduces to, using the reduction formula, tan 45 degrees. 200 is also in the third quadrant, and it is 180 plus 20. And in the third quadrant, cosine is negative, so that reduces to minus cos 20 degrees. Now studying this again, this is good news because this is a special angle, so we can replace that straight away. Tan 45 is 1. Then the challenge comes here, trying to look at the 35 above. We might not see any relationship. But if we remember again our grade 11 work, if you get stuck with an angle which is not a special angle, consider co-angles. Now the co-angle of 20 degrees is 70 degrees, and that's good news because 70 is double 35. So we are getting close. So we change cosine 20 to sine 70 degrees using co-angles. And now 1 times minus sine 70 degrees is minus sine 70 degrees, and simply take the negative here. And writing 70 as 2 times 35, as we have observed that 70 is twice 35. So write that as sine 2 times 35. Then apply double angle formula fine. That's going to be minus sine 35 cos 35 all over 2 sine 35 cos 35. And these will cancel, remaining with minus half as our answer.
Example number 3. Evaluate without using a calculator. Sine 48 degrees over sine 16 degrees minus cos 48 degrees over cos 16 degrees. The first step here is writing these as a single fraction using a common denominator. Now sine 16 degrees and cos 16 degrees do not have a common factor other than 1. So their lowest common multiple is their product. So that is our lowest common denominator, sine 16 cos 16. We obtain the numerators by the short method of cross multiplication. So that's cos 16 degrees multiplied by sine 48 degrees to give us sine 48 degrees cos 16 degrees. Then sine 16 degrees multiplied by cos 48 degrees. That gives us minus cos 48 degrees sine 16 degrees. Now studying this numerator, we see the pattern sine A cos B minus cos A sine B. Now this reminds us of the right hand side of the compound angle formula for sine. So we apply that in the reverse. It says we must subtract the two angles. So that's sine 48 degrees minus 16 degrees all over sine 16 degrees cos 16 degrees. And subtracting, this is equal to sine 32 degrees over sine 16 degrees cos 16 degrees. Here we observe that 32 is equal to 2 times 16. So that gives us an opportunity to use the double angle formula. So we rewrite 32 as 2 times 16 to have sine 2 times 16 degrees all over sine 16 degrees cos 16 degrees. Then applying the double angle formula, we have 2 sine 16 degrees cos 16 degrees all over sine 16 degrees cos 16 degrees. Now this cancels with that, and our final result 2. Here are the suggested solutions to the practice questions. In question number 1, we were asked to prove that sine 3a is equal to 3 sine a minus 4 sine cubed a. We start by rewriting 3a as 2a plus a. So we have sine 3a equal to sine 2a plus a. Then we expand this using the compound angle formula. That is sine 2a cos a plus cos 2a sine a. Next step is to get rid of the double angles using double angle formula. So here we have 2 sine a cos a multiplied by cos a. And this is the one which has 3 options to choose from. Since the result that we want is only sine, we choose the one which has sine only. And that is 1 minus 2 sine squared a, then multiplied by sine a. Next thing, multiply sine a into the bracket and multiply cos a by cos a here. That gives us 2 sine a cos squared a, and when we come here it's sine a multiplied by plus 1, that's plus sine a. Then sine a multiplied by minus 2 sine squared a gives us minus 2 sine cubed a. Now we are remaining with cos squared a to get rid of. We use the trig identity which says cos squared a is equal to 1 minus sine squared a. So substituting for that, we obtain 2 sine a into 1 minus sine squared a plus sine a minus 2 sine cubed a. And multiplying 2 sine a into the bracket, we have 2 sine a times 1 giving us 2 sine a. 2 sine a multiplied by minus sine squared a gives us minus 2 sine cubed a plus sine a minus 2 sine cubed a. Now looking at the result, we identify like terms. That's 2 sine a plus sine a. This gives us 3 sine a. Then minus 2 sine cubed a minus 2 sine cubed a gives us minus 4 sine cubed a. And this is the required result. Question 2.1. We are required to simplify sine 40 degrees, sine 50 degrees all over sine 100 degrees without the use of a calculator. The first thing is to ensure that all angles are acute angles. Now 100 degrees is not an acute angle. 100 lies in the second quadrant. It can be written as 180 minus 80. And in the second quadrant, sine is positive. So this reduces to sine 80 degrees. Now we have reduced all angles to acute angles. We try to look for relationships here. We observe that 80 is equal to twice 40. The challenge here is with sine 50 degrees. But looking at 40 and 50, we observe that they add up to 90 degrees. They are co-angles. So sine 50 degrees can be written as cos 40 degrees. Because for co-angles, the sine of one is equal to the cosine of the other. So we rewrite the numerator as sine 40 degrees cos 40 degrees. And the denominator rewriting 80 as 2 times 40. We have sine 2 into 40 degrees. Then applying the double angle formula in the denominator, we have sine 40 degrees cos 40 degrees all over 2 sine 40 degrees cos 40 degrees. Now this cancels with this, and the final result 1 over 2 or half.
2.2. We are required to simplify cos squared 22,5 degrees minus sine squared 22,5 degrees all over cos squared 22,5 plus sine squared 22,5. Now, here you are just being tested whether you can see that this thing which looks ugly is actually 1, because it's cos squared of the same angles, which is sine squared here. It's like cos squared theta plus sine squared theta, which is equal to 1. So replacing this with 1, we go to the numerator and observing that that's the right hand side of the double angle formula for cosine. So that is cos 2 times 22,5 degrees. And multiplying the angle here, that gives us cos 45 degrees, and 45 degrees is a special angle, so we can substitute the ratio straight away. That's cos 45 degrees is equal to root 2 over 2. Question 2.3. Evaluate without the use of a calculator 2 sine 105 degrees cos 225 degrees. Observing that 105 and 225 are not acute angles, we start by reducing those to acute angles using reduction formula. Now 105 is in the second quadrant, and it can be written as 180 minus 75. And in the second quadrant, sine is positive. So 2 sine 105 reduces to 2 sine 75 degrees. 225 lies in the third quadrant, and it can be written as 180 plus 45. In the third quadrant, cosine is negative. So cos 225 reduces to minus cos 45 degrees. Now cos 45 degrees has a special angle 45 degrees. So this can be substituted straight away with its ratio. And starting with that, we have minus for that minus sign. Square root of 2 over 2, which is cos 45. Then times this 2 sine 75. We split 75 into 45 plus 30. Special angles. Notice that we don't just choose any angles. We rewrite it as the sum of special angles so that we will be able to substitute for the values. Now simplifying these 2 cancels with these 2, we remain with minus square root of 2. And expanding this using compound angle formula, that is sine 45 degrees cos 30 degrees plus cos 45 degrees sine 30 degrees. Then we can now substitute the ratios. That's minus square root of 2 into sine 45 degrees is square root of 2 over 2 times cos 30 is square root of 3 over 2 plus cos 45 is square root of 2 over 2 times sine 30 is half. Then we have to multiply out the brackets, remembering that multiplication is distributive over addition. So square root of 2 will only multiply the first factor here and the first factor there. I choose here to keep the minus sign outside the bracket. So that's minus square root of 2 times the square root of 2 gives 2. That's over 2 times square root of 3 over 2. Then this must also multiply that, distributing multiplication over addition. So that's square root of 2 times square root of 2 gives us 2 over this denominator 2 times half. Now 2 over 2 is 1, then 1 times root 3 over 2 will give us root 3 over 2. Similarly here, this is 1 times half is half. Now these two fractions have a common denominator, so we can write them with one denominator. So that is minus 1 plus the square root of 3 all over 2. I have just swapped the positions of root 3 and 1 here as a convention of writing sets.
.4 Evaluate without the use of a calculator. Sine 72 degrees over sine 24 degrees minus cos 72 degrees over cos 24 degrees. We start by expressing these as a single fraction with a common denominator. The common denominator here is simply the product of these two denominators because they do not have a common factor. So our common denominator is sine 24 degrees cos 24 degrees. We find the numerators by the short method of cross multiplication. That's cos 24 times sine 72 degrees to give us sine 72 degrees cos 24 degrees. Then sine 24 degrees multiplied by minus cos 72 degrees to give us minus cos 72 degrees sine 24 degrees. Now observing this, we see the pattern sine A cos B minus cos A sine B, which is the right hand side of one of the compound angle formulae for sine. So applying that in reverse, it says we subtract the angles. So that is equal to sine 72 degrees minus 24 degrees all over sine 24 degrees cos 24 degrees. Simplifying, that gives us sine 48 degrees all over sine 24 degrees cos 24 degrees. And observing that 48 is twice 24, we rewrite 48 as 2 times 24 so that we can use the double angle formula. So that gives us sine 2 times 24 degrees all over sine 24 degrees cos 24 degrees. Applying the double angle formula for sine, that gives us 2 sine 24 degrees cos 24 degrees all over sine 24 degrees cos 24 degrees. Now sine 24 cos 24 cancels with sine 24 cos 24, leaving us with 2 as our final answer.